We have seen an example of cross validation. We took the overall training data and we took 80% of it and called it as training data, and remaining 20% is holdout data. Now we did that once. Where if we do it 10 times, then it is called tenfold cross validation. Let us see how it is done. So divide the whole data set into 10 parts randomly, use 9 parts as the training data and the 10th part as the holdout data. So we build 10 models. So we repeat this whole process 10 times, build 10 models, find the average error. Now that really gives us the actual training error. So even the smallest error that we are making by choosing the training data 80%, test data 20%, I mean, if there would have been like one small error, even we can reduce that by doing this tenfold cross validation. So how it is done? Let us suppose this is the overall data set. We divide it into 10 parts. While building model 1, we can use all this data as training and remaining this one data set, which is 10% of the overall data, as testing, and find out what is the training error, what is the test error. In the next model, so this is model 1, M1. While building the next model, we will use all these 9 parts except the 9th one. We will use 1 to 8 and the 10th part as the training data, this as the testing data, and build model M2, find the training error and test error, note them down. Similarly, we repeat the same process. In the last step, we will leave out the first one as the holdout data. Remaining 9 parts, which is 90% of the data, consider that as the training data and build the model M10 and use it as training data and use the first part as test data, find out the error. So that is how we can do k-fold cross validation, which will have 10 errors. So on an average, we can find the overall training error and test error that will give us a solid idea on what is the overall accuracy of the model that we are building. In fact, we can even generalize this to k-fold cross validation. So here we divided the whole data into 10 parts. We can divide the whole data into k parts. I mean, we are generalizing the 10 parts into k equal parts. Keep aside the one of the part, use remaining all parts as the training data and test it on the part that is left out. So if the k value is 10, then it will become tenfold cross validation. If k value is 5, then 80% of the data will be considered for training, 20% will be considered for testing. So k-fold is just a general version of tenfold cross validation. So if the k-fold cross validation is the method that we are following, then we will be building k models, and the average error on the holdout sample gives us an idea on the overall testing error. So how do we choose the best model when we are doing this kind of k-fold cross validation or tenfold cross validation? Okay, choose the model that has least error and least complexity. That means that is simple as well as which is capturing most of the information, or the model with less than average error. On the average there is some error. The model with less than average error but looks simple, that means which has least parameters. So we can finally build a different model using the overall data set with those many parameters. So we can at least get an idea on the overall error and the complexity of the model, and then we can take the overall training data set, use the same complexity and rebuild the model and say that is our final model. So at least we will not be saying that 95% is the accuracy of our model. Every time in this k-fold or tenfold, every time we are getting an accuracy of 80% only, then we should have a basic idea that our data or our model is good for only 80% of the accuracy. It is not having 95% accuracy. So that gives us a good idea on the overall accuracy as well as the real predictive power of the model. Generally in k-fold cross validation, it's better to choose k between 5 and 10. In fact, 10-fold cross validation is nothing but k equal to 10, which gives 80 to 90% training data, and the rest of the 20 to 10% is the holdout data set.